Hi, welcome to session 7 on this module on systematic review. This week we'll be looking at data extraction. The next 2 weeks are focused on data extraction and risk of bias judgments. You should come away from these next 2 weeks confident that you can undertake data extraction and make risk of bias judgments reliably. In terms of the action points that you're completed to make use of this session, I'm assuming you will have recorded your search terms using the PRISMA S checklist, that you have checked other people's search terms and had your own checked using the PRESS checklist, and if you're in the Teams channel with this module, you'll see that there is a list where you can match up with someone else from one of the other reviews, so you can have your terms checked and so you can check their terms. You will have completed all your searches in Central, Ovid Medline, Ovid PsycInfo, Ovid Embase, and Web of Science. You will have imported your search results into Endnote and recorded your total, and you would have documented this according to PRISMA 2020. You will have then taken that Endnote library that contains all those records and deduplicated them in Dedupatron, in SR Accelerator. You would have subsequently confirmed your eligibility criteria as per the PRISMA guidance, and you will have checked this with your supervisor. You will have completed abstract screening in Screenatron and recorded your decisions and resolved your disagreements in Disputatron in SR Accelerator and complete the first 2 lines of your PRISMA flow diagram. And last week, you will have confirmed your full text eligibility operationalization. You will have retrieved the full text, split screening by pairs, undertaken screening in Screenatron and recorded your agreement and resolved disputes. You will have reported reasons for exclusion on your PRISMA flow diagram. If you found reviews in your full text screening, you will have searched the citations and then taken that citation database and deduplicated it, put it through Screenatron, resolved disputes in Screenatron, and retrieved those full text. And the recording of those decisions and disagreements and reasons for exclusion will have also been added to your PRISMA 2020 flow diagram. So this is the PRISMA 2020 flow diagram that we'll be using. Assuming we're including papers that we found in reviews, you will have seen the other version that doesn't include the section to the right if you're not doing citation searching. Anyway, at this stage, hopefully you're at the point where, regardless of whether you've done citation searching or not, you now know how many papers are going to be included in your review. Now, if you're not at that stage and you're still doing full text screening, I just want to highlight to you this service, which is called Endnote Click and used to be called Copernio. And I've put the link to the service at the top of the page there. This is an add-in to Chrome that looks for full text. It's a useful addition to Endnote, because obviously Endnote has its find PDF function. You'll see that when you go to that link, you add in an extension to your Chrome browser, and when you go to a journal website, what you'll see is an overlay pops up asking you if you want to retrieve the full text, and you click on the link and it will take you to the PDF. Hi, this is Kellar here for the Systematic Review module at the University of Leeds. Today I'm talking you through Endnote Click or Copernio, and this is a helpful addition to the find PDF function within Endnote. I think I've mentioned it's been reviewed positively by the Journal of the Medical Library Association, and they seem to be fairly positive about it. It's an add-in for Chrome, so when you click the link that I've sent you, you'll be prompted to add it to Chrome, and then it'll be an extension that you can add to your toolbar up the top. So just make sure that when you're using it, that you have it pinned. Let's say I'm conducting a search on Google Scholar. And here I've done a search for fruit and vegetables implementation intentions. When I'm on the Google Scholar page, you'll see that the Endnote Click icon in the toolbar is there, and you can see it shows that it can find various things in Google Scholar. But if you click on the link to the journal, you'll see that an overlay has appeared in the bottom left-hand corner, and now I can just click that and the PDF becomes available, and it gives us options, various options down the side to download the PDF, share the PDF, or export it to Endnote. You can push it to your Endnote web account if you've got an Endnote web account, and so on. So this seems to me to be a relatively useful addition on top of the Find PDF function within Endnote. I hope that's helpful. Okay, so this week we're going to check on our screening progress, look at data extraction. We are going to look at a data extraction tool from Cochrane. We're going to look at our options in terms of data items. Going to look at how we can extract study characteristics and our results, and I'll introduce you to risk of bias. And the main thing we need to do this week is check on your screening progress and make sure that that's completed. And this week I'm going to talk to you about data extraction and introduce to you a data extraction tool. I'm going to talk you through using that data extraction tool and talk to you about how you can use that to record the study characteristics and detail the different conditions and extract and record the study results. So in terms of the guidance in the 2020 version of PRISMA, in terms of the data collection process, Item 9 says that we must specify the methods used to collect data from reports, including how many reviewers collected data from each report, whether they worked independently, any processes for obtaining or confirming data from study investigators. This is because review authors need to report the methods used to collect data from reports of included studies to enable readers to assess the potential for errors in the data presented. And the essential elements are that we report how many reviewers collected data from each report, whether multiple reviewers worked independently or not, so was the data collected by one reviewer and checked for another, and any processes used to resolve disagreements. So in our case, we are going to double extract everything and then have an independent person review disagreements. The other essential elements are that we report processes used to obtain or confirm any relevant data from study investigators, such as how they were contacted, what data was sought and success in obtaining necessary information, and whether any decision rules were used from multiple reports related to a study, and what steps were taken, if any, to resolve inconsistencies across reports, reporting the rules and steps used. So in terms of data items, PRISMA 2020 item 10 says that we must list and define all outcomes for which data was sought, specify whether all results that were compatible with each outcome domain in each study were sought, for example, for all measures, time points, analyses, and if not, the methods that were used to decide which results to collect. And this is because defining outcomes in systematic reviews generally involves specifying outcome domains such as pain and the time frame of measurement such as less than 6 months. And included studies may report multiple results that are eligible for inclusion within an outcome definition. For example, a study may report 2 different measures of pain, such as the MECIR pain questionnaire and the brief pain inventory, at 2 time points, such as at 4 weeks and 8 weeks, and these are both compatible with a review outcome defined as less than 6 months. Examples of processes to select results include selecting the outcome definition that was most common across studies, the outcome definition that review authors considered best according to a pre-specified hierarchy such as a core outcome set, or whichever the original study considered most important, such as the study's primary outcome. it is important to specify methods that we use to select results when multiple results were available so that users can judge the appropriateness of these methods and whether there's any potential for bias in the selection of results. In terms of the other data that we need to extract, PRISMA item 10b says we must list and define all other variables for which data were sought, such as participant and intervention characteristics and funding sources, and we must describe any assumptions made about missing or unclear information. We should report data and information collected from studies so that readers can understand the type of information sought and to inform data collection in other similar reviews. So this might include the characteristics of the study, such as the country, the settings, the number of centres, funding sources, whether the study was pre-registered, characteristics of the study design, such as whether it was randomised or non-randomised, characteristics of the participants, such as age, sex and socioeconomic status, the number of participants enrolled and those included in analyses, any results such as summary statistics, estimates of effects, measures of precision, factors adjusted for in analyses, and any competing interests of the study authors. Now, whilst we must list and define all the variables for which data was sought, it may be sufficient to report a brief summary of the information collected if the data collection and dictionary forms are available, such as in additional files or deposited in a publicly available repository. But what we must do is describe any assumptions made about any missing or unclear information from the studies. So, for example, in a study that includes children and adolescents, for which the age range was not specified, authors might assume that the oldest participants would be 18. This might be based on what was observed in similar studies included in the review. And this assumption should be reported explicitly. In terms of further guidance that's available in terms of how we should undertake our data extraction, the methodological expectations of Cochrane intervention reviews are the methodological standards to which all Cochrane protocol reviews and updates are expected to adhere. They're divided into sections for the conduct and reporting of reviews of interventions, and they provide users and authors in the Cochrane library with clear, transparent expectations of review, conduct and reporting. Now, we don't have to stick to it, but it is a really useful guide to good practice. And in section 1.7 under collecting data for included studies, we have items C43 to 51, which gives guidance on data collection. Later sections such as C52 to C60 covers risk of bias, so we'll come back to that next week. And section R1 to R109 covers reporting, so we'll be back to that the week after. So under section C43, using data collection forms, it's mandatory to use a data collection form that has been pilot. Using a data collection form ensures some consistency in the process of data extraction, and it's necessary when comparing data extracted in duplicate, so when you've got a pair of reviewers. Completed data collection forms should be available on request, and piloting within the review team is highly desirable. Section C44 on describing studies says that we must collect characteristics of included studies in sufficient detail to populate a table of characteristics of included studies. The basic characteristics of each study need to be presented as part of the review, detailing the participants' interventions, comparators, outcomes, and study designs. C45 on extracting study characteristics in duplicate says it's highly desirable to use at least 2 people working independently to extract study characteristics from reports of each study and define in advance the process for resolving disagreements. Duplicating the data extraction process reduces the risk of both making mistakes and the possibility that data selection is influenced by a single person's biases. It's acknowledged that dual data extraction may be less important for study characteristics than outcome data, so it's not a mandatory standard for extracting study characteristics. However, C46 on extracting outcome data says that doing that in duplicate is mandatory, so we must use at least 2 people working independently to extract outcome data for reports of each study and define in advance the process of resolving disagreements. Duplicating the data extraction process reduces the risk of making mistakes, and we'll come to that later, and the possibility that data selection is influenced by a single person's biases. Dual data extraction is particularly important where the outcome data directly feeds into the synthesis of the evidence. Section C48 on examining errata. It's mandatory to examine any relevant retraction statements and errata for information. Because some studies may have been found to be fraudulent or may have been retracted since publication for other reasons, it's important to go back and look for these. Errata can reveal important imitations or even fatal flaws in included studies, and all of these may lead to the potential exclusion of a study from a review or meta-analysis. Care should be taken to ensure that this information is retrieved in all database searches by downloading the appropriate fields together with the citation data. So this is particularly easy to look for if you're using Web of Science records. C49 on obtaining unpublished data. It's highly desirable to seek unpublished information that's missing from reports of included studies. Contacting study authors to obtain or confirm data makes the review more complete and potentially enhances the precision, reduces the impact of reporting biases. Missing information includes details to inform risk of bias assessments, details of interventions and outcomes, and study results, including breakdown of the results by important subgroups. Section C50 gives guidance on choosing interventions in multi-arm studies. If a study is included with more than 2 intervention arms, we include in the review only the interventions that meet the eligibility criteria. There is no point including irrelevant interventions in the review. However, authors should make it clear in the table of characteristics of included studies that these interventions were present in the study. Section C51 on checking the accuracy of numerical data in the review. This is mandatory. Compare the magnitude and direction of effects reported by studies with how they're presented in the review, taking account of legitimate differences. This is a reasonably straightforward way for authors to check a number of potential problems, including typographic errors in study reports, accuracy of data collection and manipulation, and data entry into any analysis software. For example, the direction of a standardized mean difference may accidentally be wrong in your review. A basic check is to ensure the same qualitative findings, e.g. the direction of effect and the statistical significance, between the data as presented in the review and the data available from the original studies. Results, if you've done meta-analysis, results in forest plots should agree with the data in the original report if the same effect measure and statistical model is used. All this guidance on checking, you'll have noticed a number of items there on checking that you've got data the right way. Much as it's easy to misunderstand Doom, it's easy to misunderstand study reports. A famous example of this is detailed in the paper Is Cybermedicine Killing You? The Story of a Cochrane Disaster. And this reports an account of some errors that were made in a review of interactive healthcare applications, or what we would now call apps, but that's what they were described as in the literature in 2005. Back then, author Professor Elizabeth Murray led on a review that seemed to indicate that looking for health advice on the internet was bad for you. And academic Lee Ritterband, whose research was cited in the review, in this Cochrane review, but who had not seen a preprint of it prior to publication, was alarmed by the media reports. And he commented in a mailing list for internet health intervention researchers that whilst it is possible for some people to be worse off, we know that our interventions are quite effective. And these kind of fear-inducing findings are the type of comments which our research in part must debunk. Per Egil Kummervold and colleagues at the Norwegian Centre for Telemedicine had also noticed that the numbers in the review didn't add up. And these two groups started a thorough investigation, reviewing the original data material. And in October the 28th, they notified the Cochrane collaboration that the authors had made some terrible mistakes, including swapping the direction of the results. And by the 29th of October, the review was retracted. And there's an example of one of the original reports. And so in that article, Is Cybermedicine Killing You?, they demonstrate some of the nature of the errors that were made. You can see there that, as an example, in Brown 1997, where the outcome was HbA1c, which is a measure of your stability of your blood glucose control, Table 1 reported an increase in HbA1c of 0.68 for the intervention group and an increase of 0.66 for the control group. And unfortunately, this was reported as a benefit for the intervention group, whereas actually it's negative because you don't want your HbA1c going up. And similarly, in Glasgow 2003 was interpreted wrongly because the intervention group, HbA1c, reduced by 0.12 for the intervention group and increased in the control group. And whilst they got the numbers right, they misunderstood that a reduction in HbA1c favours intervention. Similarly, with the Krishna paper from 2003, they misinterpreted a reduction in asthma symptoms of 80 days and a reduction of 50 days in the control group as being beneficial for the control group. And you can see a similar mistake was made for Lehman, and a similar mistake was made for Turn in 1992 and 2001, and a similar mistake in Wiley-Rosette. So this is the methodological expectations of Cochrane intervention reviews form. And the way to see it is as a guide for developing your own data extraction forms. So there's a lot of sections in here, and these can be expanded and added to or removed if they're irrelevant. And because it's difficult for anyone to design a single form that meets the needs of all reviews, it's important that you consider what information you need for your review and adapt this form accordingly. Using this form or an adaptation of it will help you meet the methodological expectation of Cochrane intervention review standards for collecting and reporting information about studies for your review. So key notes on how to use this form are: be consistent in the order and style you use to describe the information for each report, record any missing information as unclear or not described to make it clear that the information was not found in the study report, not that you just forgot. And as we've said previously, include any instructions and decision rules either on the form or in an accompanying document, so it's clear how pairs of reviewers or teams of reviewers should use it and to help them be consistent. It's important before you start using this form in anger that as a review team, you practice using the form together and train each other on how you should use it. So we recommend doing at least one of the studies as a team together. On this first page, you have some identifying details. So in the first box, you're identifying the title of your review. And in the second box, you're identifying the study ID. And then you'll see below this, the report ID and report ID of other reports of this study. The way to understand this is that for any study, there may be multiple reports. There may be a protocol of the study, there may be a feasibility study, there may be a main trial that reports primary outcomes, and there may be subsequent follow-up papers that report secondary outcomes and process analyses. And each of those reports for a study may be useful in describing what went on in the study. So you give the study an ID, and then you give the report an ID, and you also link to other reports of the same study. Under general information, you just describe the date that you completed it, your name, the citation for this paper that you're working on, any contact details for the author, what type of publication it is, and any notes. So under the section on study eligibility, you record whether this report of the study indicates that it meets study eligibility. You check whether it meets the study type eligibility criteria, whether it meets the participant intervention comparator outcome eligibility criteria. And then you choose whether to include it or exclude it and give your reason there. So remember, just as before with screening, you only need to tick the first one as a no and you can stop. The next section is the characteristics of included studies. So there, the descriptions are meant to be as stated in the report paper. So I would cut and paste. So you want to paste in the aim of the study, the design, so the unit of allocation. So I suspect for most of you, you're going to find that it's individually allocated, but potentially if people are allocated by setting, such as by school or by hospital or by general practice, then you'll be cluster randomized. So the unit of allocation is cluster. Put the start and the end date of the study if it's available. Remember, if it's not reported, make clear it's not reported. And then the duration of the study from first recruitment to last follow-up. If ethical approval is reported, tick yes. If it's not reported, click unclear. Now under participants again, any information about the intervention and comparison group needs to be provided. So what the population is, what the setting is, detailing the inclusion-exclusion criteria, detailing method of recruitment, any mention of informed consent, place it here. Under the total number randomized, if there's a consort flow diagram, you'll find that at the top. The number of clusters you could report here. Any analysis of baseline imbalances you can report here. Any detail of withdrawals or exclusions, place those there. Details of participant characteristics such as age, sex, race, or ethnicity, severity of illness, comorbidities, other relevant demographic factors, pop those in there. If there's any analysis by subgroup, you can place that here in terms of how the subgroup was separated, and you can detail the number of subgroups reported here. In terms of the intervention, obviously you're going to need to cut and paste extra intervention group sections depending on how many intervention groups you've got. So this is for where you've got one intervention group. You need to give it a name. You're going to need to look in the consort flow diagram as to how many were randomized to this group. Any details of the theoretical basis of the intervention, pop that here. Then cut and paste in the description of the intervention, duration of treatment period, any details of the timing or frequency of the intervention, any details of the delivery mechanism of the intervention, any details about who delivered the intervention here. If there were other interventions delivered at the same time, so for example, say your intervention was tested against usual care, and in the intervention group they got usual care plus something else, detail what usual care was in the co-intervention. Any details of the cost of the intervention could be put here. Any details of the resource required, you could place that here. So if you find that the report contains a logic model, you might find the resource in there. If there's any reporting of intervention fidelity, you can pop that down towards the bottom of the page. So that's, was it delivered as described? And where, in terms of whether people adhered to the intervention, you can place that at the bottom there. Now, just as you'll need to paste a new section each time for intervention, if you've got more than one intervention condition, you're going to need to cut and paste an outcome section each time you've got an extra outcome of interest. So pop in the outcome name, pop in the number of time points measured, pop in the number of time points actually reported, give a definition of the outcome. If you've got any details of people doing the measurement, pop that in there. If relevant, include the unit of measurement. So it may be that some outcomes could be reported according to different measurement scales, such as HbA1c can be measured can be reported in a number of ways. Give details of the direction that favours intervention and any details of the scale. If there's any detail of validation of the outcome, pop that in here. If there was any treatment of missing data, you can put that in here. If there's any detail of the baseline risk of this outcome, pop that in there. If you've got details of the power calculation that was done for this outcome, pop that in at the bottom. If you've got detail of funding, paste that in there. And if you can see any conflicts of interest, you may find that in disclosures in the article. You need to paste that in too. Now, you'll find in the document there is a risk of bias assessment. I don't want you to use this. There is a separate risk of bias to crib sheet and a risk of bias to macro that you should use. Now, once you've decided what outcome you're interested in and what time point you're interested in, remembering that you need a rationale for your decision as to what time point to include, you can then copy and paste as many of the sections as you need. For most of you, I suspect you're going to have rules as to which one outcome you choose and which one time point you choose. So assuming you've done that, you're just going to need the one section like this. So the first bit you need to paste in is what the comparison is. So your named intervention and your control group. And it may be, like I've said previously, you need to have rules around which intervention condition and potentially even which control condition you select. Once you've done that, then you detail the outcome measure itself, whether this analysis was done in a specific subgroup, and I suspect for most of you, you're not selecting subgroup analyses within reports, you're looking in the whole sample. Describe the time point that you've selected here. And then in the results section, how many people were in this group and how many people were included in this analysis. Any details of the reported analysis can be pasted in the any other results reported section. Detail missing participants in each case, and if there's any detail of why they're missing, paste that in under reasons missing. If there was any reason that people were moved groups, hopefully there won't be, but if that's the case, you can pop that in the section there and describe there the unit of analysis, so whether people are being analysed as individuals or as clusters, and any details of the statistical methods used in the bottom section there. Now, I can't imagine you guys will be doing any reanalysis, so I suspect you'll be able to ignore this whole section at the top here. So now we're on to the outcome section, and this first section is for dichotomous outcomes. So this is for outcomes where it's either a thing or not a thing, rather than a continuous outcome. So, mortality, you're either dead or you're not, as opposed to morbidity, where you have different levels of illness. So the first thing you want to do is put in the comparison. So there you want to describe what intervention versus what comparison condition you're looking at, and you want to define the outcome. If there's some kind of subgroup analysis as well, you want to state that there. Be clear which subgroups that you're looking at, and you also want to be clear what time point you're looking at. Then in the next section, you want to describe the number of people in the group with the number of people who have the event, the dichotomous outcome that you're interested in, and in the comparison group, the total that were in the group versus the total with the event. If there are any other statistics conducted on this outcome, you want to paste them into that section below there. And if there are missing participants, you want to put the details of how many were missing and the reasons they were missing described in the paper. If any participants were moved from one group to another, you want to describe that there and any rationale for that below. In terms of the unit of analysis, so whether it was groups of people or wards or schools, you want to describe that there. I think most of you it'll be individual level analysis, but there may be some of you where it's analysed by cluster, and the statistical methods that were used. So put the details of the analysis in that section below. I can't imagine any of you are doing reanalysis, but that's where you would record whether reanalysis was possible and required. And then you can put some more notes at the bottom there. Now we're on to the next section. This is the section that I'm most used to using. This is for when you have an outcome that's a continuous outcome. So again, I'd be describing the comparison there, defining the outcome, talking about any subgroup analysis, being clear about what time point I was using. Here I would be clear about, in the next section where it says post-intervention or change from baseline, I would be clear about what analysis was being done. So for most of my analyses, I would be looking at, they would have controlled for baseline, but they'd be looking at difference in follow-up between the intervention and control group. In the results section, you'd put the mean, standard deviation, and number of participants per cell, or per arm, so in the intervention group and the comparison group, and you would report the statistics beneath that. If there are missing participants, you'd record them here and the reasons that they were missing. If participants were moved from one group to another, you need to be clear about that. And again, you need to be clear about the unit of analyses. You need to describe the statistical methods here. And again, you have opportunity to describe whether reanalysis was required. And then the next section is for other type of outcomes. So again, same sort of items there. And then after that, for controlled before and after studies. So if any of you have used those kind of designs, you can put that in there. So again, exactly the same items on the form as before. I can't imagine any of you will be using interrupted time series, but if you were, you have opportunity to enter that data on the form here. Again, similar sort of items as previously. So you've been clear now on the structure of the form. You have a section describing the details of the study, so kind of the overall study design, then some details on the different conditions, so a section that you fill in for the intervention and you copy for the comparison. And if you have multiple intervention conditions or multiple comparison conditions, you copy that section. And then you have a section for different types of outcome, so whichever type you've got, you copy that for as many times as you are looking at different outcomes. So for the most part, what I tend to do is just have one intervention and one comparison condition that I describe, and then I typically have one outcome, and that's typically for me a continuous outcome. So I would cut out those other sections and I would just simply have the description of the study and the design, and then I would have the intervention section, which I would then copy and use for the comparison section, and I would have one continuous outcome section. So you copy and paste the different elements of that form as required and turn it into your own version. Now, the basic version is in Word and it's easy to edit, and entering the data is simply entering data into Word. Now, you might find that that's not the ideal way of doing it. I do like that because I can jump back and forth, but you might not like that. You might want to turn the form into a Google form and then enter each bit in sequence. Or you might want to turn it into an Excel sheet because then you can have all your records easily in one place. I tend to just make a different form for each report that I'm including, and just call that good enough. Some other of you might want to use dedicated systematic review software, so software like RevMan, but there are lots of other options. But 99% of the time on this module, people just use Word. Reviews are only as good as the studies that feed into them. If you put poor quality studies in, you'll get poor quality studies out. So the extent to which a review can draw conclusions about the effect of an intervention depends on the data and the results of the included studies and the extent to which those studies are valid. Invalid studies may produce a misleading result. Evaluation of the validity of included studies is an essential component of a review and should influence the analysis, interpretation, and conclusions of a review. Empirical evidence of bias in randomized control trials comes from a field known as meta-epidemiology. Meta-epidemiological studies analyze the results of a large collection of previous studies to understand how the characteristics of studies, so the methodological characteristics of studies, are associated with their results. A famous meta-epidemiological study by Schultz in 1995 examined 33 meta-analyses containing 250 trials. Each study was categorized on the basis of 4 characteristics: whether sequence generation was reported to have a random component, whether allocation was adequately concealed, whether the trial was reported as double-blind, and whether the trial reported exclusions of participants from its analyses. For each of these characteristics, trials were compared within each meta-analysis to estimate a ratio of odds ratios amongst the better versus worse trials, and these ratios of odds ratios were combined across the 33 meta-analyses. Compared with trials in which authors reported adequate concealed treatment allocations, trials in which concealment was either inadequate or unclear, i.e. they did not report, or incompletely reported concealment approach, yielded significantly larger estimates of treatment effects. Odds ratios were exaggerated by 41% for inadequately concealed trials and by 30% for unclearly concealed trials, following adjustment for other aspects of quality. Trials in which participants have been excluded after randomization did not yield larger effects, but that lack of association may be due to incomplete reporting. Trials which were not double-blind yielded significantly larger estimates of effect, with odds ratios being exaggerated by 17%. Schultz reported, "Our findings not only highlight the importance of adequate methodological quality in controlled trials, but also the importance of complete and reliable reporting. Without adequate reporting, assessing quality becomes impossible. Authors should, at a minimum, explicitly describe their approaches to sequence generation, allocation concealment, blinding, and handling of exclusion after allocation. Preventing foreknowledge of treatment allocation by effective concealment of allocation in controlled trials emerges from our analyses as crucially important to reducing bias. Without the proper allocation of measures to achieve concealment, the whole point of randomization vanishes and bias is likely to distort results." What do you need to do over the next week? Well, first of all, you need to make sure all your screening is complete. That's the first thing. And then the next thing you need to make sure is that you have a clear primary outcome. So look through the studies that have passed screening with your supervisor and make sure that you're clear on what you're interested in as the primary outcome. Subsequently, you're going to need to amend the data extraction form, so make sure that you have the correct outcome measures, you have enough intervention and control conditions, and make sure that's all sorted and check that with your supervisor and your PGTA. And then you need to double extract a manuscript, at least one, as a study team, so you're all clear on how the data extraction form works and you're all extracting consistently. So next week will be a data extraction and risk of bias workshop, so you must get all your screening done by next week. We're going to have a chance to troubleshoot data extraction cases, so if you've got a problem with your form or you're not clear how to use it, as long as you've done one, we can talk you through that next week. We're also going to look at risk of bias next week, so we're going to look at the risk of bias 2 tool from Cochrane. You need to have a first sweep of at least one paper by next week, otherwise you won't get as much out of next week's session as you could. So it's really important that over the next week you've got all your screening done and that as a study team you're clear about what your primary outcome is, and you've created your data extraction form and you've all had at least one go with it on the same manuscript, so you're all calibrated. So please make this progress. Okay, I shall see you next week.